On November 9, 2011, the Chesapeake Bay Foundation, or CBF, released a video that claimed to show releases of methane from drilling operations, compression stations, and other equipment used in the production and transportation of natural gas. Cornell University professor Robert Howarth is presented as an expert and describes the raw footage as proof that invisible methane is either escaping uncontrolled or being vented intentionally. Professor Howarth could not be more wrong. The emissions actually are normal combustion exhaust from natural gas-fired boilers or conventional engines operating on the sites. Energy in Depth traveled to Cornell University and recorded FLIR footage of the emissions from the exhaust stacks of their campus power plant, as well as filming other combustion sources. This power plant, just like a natural gas drilling operation, is not emitting concentrated methane, but the exhaust vapors demonstrate the same FLIR image characteristics of those described by Howarth. Energy in Depth also spoke to Dr. Ram Hashmani, a principal consultant for Environ and an international expert in the implementation of optical remote sensing. Dr. Hashmani is the inventor and developer of many optical remote sensing techniques, such as the radial plume mapping method, and also holds several U.S. patents in the area of optical remote sensing. Dr. Hashmani reviewed Howarth's findings to shed new light on what is actually seen.
If the pressure gets too high, they have to let it go, and yeah, there it is. It's a lot of gas flowing out of that one. They have the capability of flaring it, that is burning it and turning it to carbon dioxide instead of just venting it like this. But they don't like to do it because it draws public attention. It makes a lot of noise. It disturbs people.
First of all, what I see in this image is a very hot stack with very hot plume of gases coming off that stack, which are not necessarily hydrocarbons, which indicate this is a combustion source. This is from a distance. We can see things, but it dissipates. We can see, sometimes you see the wind comes in and it's fold the plume, and you see that we don't see anything coming on the sides. We don't see, it's even disappearing before it's going out of the frame. That's you see, when the plume is short, that means that we have like a wind coming off. You see, I show you right now. Right now, the plume is short, and you can see there is no trailing of hydrocarbons. There is nothing on the background. It's all clean around here.
To demonstrate this point, a gas grill was filmed with the same infrared technology to show what hydrocarbons look like before they are ignited.
The gas grill clip shows that when the hydrocarbon gas, is in the same temperature as the air around it, it can be visible on the sky background for a long distance downwind from the source. When you light it up, what you'll see is something very similar to a combustion source. You will see the hot plume coming off the gas grill and dissipate very quickly on the sky background.
Methane is completely invisible to the naked eye, but it strongly absorbs the infrared radiation. That's what makes it such a powerful greenhouse gas. It's absorbing that infrared, and that camera is picked up to mimic that same wavelength, so that's what you're seeing.
In this site, we can see in the FLIR clip that there are many flickering temperature differences. It could be hot gases or heat waves, but if there were any substantial emissions of hydrocarbon, we would see it all over the sky background, and it will not disappear.
Yeah, so that's really impressive venting. Again, that's purposeful. It's not a leak. It's not an accident. It's how they maintain the pressures in their storage tanks and pipeline facilities.
This is even a better example of a combustion source with a hot stack, hot plume that dissipates very quickly as it cools off. And we have a larger take here of the sky background, and there is no evidence of significant hydrocarbon all around that frame. The cigarette lighter demonstration simulates a flare. A not working flare is when you release the gas directly without the flame into the atmosphere. Then you can see a lingering plume that goes a long way in dimension compared to the size of the flare, and linger for a long time. And when you ignite the flame, you would see a heat waves above it that will go until the non-hydrocarbon hot gases will cool off and will be in the same temperature as the air around it. This clip is another example of very hot combustion sources with hot stacks and very hot plume rising really high. They do not show any evidence of trailing hydrocarbons on the very cold sky background. In conclusion, I did not see clear clips here that show what I used to see in FLIR videos, images that indicates any substantial hydrocarbon leaving any of these sites. With all the examples that they gave were mostly combustion sources and they are not indicative of any hydrocarbon leaks. I also know that most combustion sources do not emit hydrocarbons in the level that can be monitored or detected by the FLIR camera technology.
According to Dr. Hashmanai's review, the Chesapeake Bay Foundation's claims are incorrect for two reasons. One, Dr. Howarth has mistaken the FLIR camera images as venting of methane when the images are of stack emissions from hot combustion sources. Two, if there were significant hydrocarbon emissions taking place, they would have been picked up by the FLIR camera, as demonstrated by the propane grill and cigarette lighter before they were lit. A FLIR camera image taken of a boiling tea kettle will show what looks to be substantial hydrocarbon emissions, but in reality, no methane or other hydrocarbon emissions are being vented. This further underlines that the Chesapeake Bay Foundation's claims are baseless and untrue, and that Professor Howarth of Cornell, whose previous studies attacking natural gas have also been shown to be false by independent scientists, is once again wrong in his analysis. For more information on this and other issues, visit us at energyindepth.org.